Hi viewers, so today we are going to see the next model problem. In case of a last video we have gone through the epicycloid, right? Previously we have gone through cycloid, and now we are going for hypocycloid curve, which is a very another important model and very small corrections compared to that epicycloid. So here in hypocycloid, the curve, a circle which rolls inside of another circle. That's a very important one. A circle, for example, so in a hypocycloid we have gone through already. This is called as a base circle. Okay, a circle which is rolling inside of another circle. So it tends to roll like in this direction, right? So I can say it is in an anti-clockwise direction. So if it rolls, how the shape of the curve we are going to get? That's what we are going to learn. It's inside of another circle, so it's entirely a little bit opposite to the epicycloid curve, right? The procedure almost remains same, only thing the way how you are going to draw it. Now in a hypocycloid problem, this is the data I am going to take it today. Hypocycloid, it's a draw a hypocycloid of a circle of 40 mm diameter which rolls inside of another circle of 200 mm diameter for one complete revolution. So small d we are going to take it as 40 mm and capital D is 200 mm here. Okay, it's 200. So this is the data they are given here. So with this data we are going to start the problem. Now the first step, as usual procedure, so capture the center point of here. Okay, let me capture the center point here and just draw one small reference line. Okay, now let me give this particular point as name as O. Then with this O I am going to draw two lines at an angle, but before drawing it I need to find out the theta value. I already told you in epicycler the same formula, theta equal to small r by capital R into 360. So small r is 20 divided by 100 into 360. So now the theta value you are going to get, it will be is equal to 72 degree, right? So theta is 72. Okay, this is the value you are going to get. So now I am going to draw two lines. Okay, before drawing the two lines, first you draw a base circle. Okay, what is the base circle diameter they are given? Its diameter is 200. So we need to take radius as 100 mm. Place your compass at here. Draw a circle or an arc. Okay, we are going to draw an arc at a radius of 100 mm. So this is a major region we are going to get. Okay, so this is a major region we are going to get. Now next step what I am going to do is I am going to mark the 72 degree here. So 72 I am going to divide into two divisions, right? So it will be 36 degree, because I am making the angle at the two equal arcs. So place your protractor like in this direction, mark 36 here, and reverse the protractor here in this direction and mark 36 here. The same thing we have done already. So 36 degree means you may tend to get it like in this manner, and similarly here also you may tend to get it like in this manner. Yes, absolutely. Okay, later you erase the unwanted lines or unwanted arc. Okay, just analyze it. So this is the portion we will get it, and these two regions the angle will be 72 degree. This entire region the angle is theta equal to 72. Now I am dividing this. Okay, anyhow we can draw a thin center line for this one. Okay, in such a way for it's easy to understand. It's a thin center line in such a manner. This is a center point. Okay, from this point you just draw a vertical line. Okay, now before that, next step, we need to draw a rolling circle. Here the rolling circle diameter is, it's 40 mm. It rolls inside, right? So let me give this point name as, let it be P, and this point name as Q. Okay, so from this point measure the distance of C and mark this point C here. Okay, so this is C. Okay, with PC the value will be equal to 20 mm. Now you place your compass at the point C and take the radius of 20 mm. In such a manner you will get a circle Okay, so this is the manner you used to get it. Okay, so you will get a circle like in this manner, and I think the C little bit, it will be little bit below on that as per the measurement. If you draw, you will get it. Okay, now I drawn a rolling circle here. Okay, so of the 20 mm, of the radius 20 mm. Now since here it is tends to rolls in a anti-clockwise direction, am I right? The circle, rolling circle, it tends to roll in a anti-clockwise direction, so the numbering will be in clockwise direction. That's very important. So numbering, I am going to give start from here. 1 2 3 4 5 and 6th will be here. 1 2 3 4 5 and 6. We are getting 7 8 and 9 10 11. The 12th point is the last most one. Okay, so this is 6th point, and just give the namings 8 9 10 11 and 12. The numbering is very important. If you are tends to do any mistakes or in the numbering direction or something, you have done any errors, then definitely you won't get a perfect hyperbolic curve. You will be facing troubles in drawing that. Okay, now this is the next step. So what I am going to do is, next step, place your compass at the point O. What we done for epicycloidal curve, the same thing. Now with O6, this is the lowermost point of the circle. With O6 as a radius, just draw an arc. Next step, with O7 as radius, just draw an arc in such a manner it will intersect at the point 5. Okay. Okay. Then O8, it will intersect at the manner point 4. I think little bit. Okay, so this is the 4th point. Okay, and this is the locus of center, and O9, it will intersect at the point 3 and it will be coming like in this manner. Then O10, it will intersect at the point 2 and the arc will be coming like in this manner. And with O11 as radius, place your compass at the point O, just join this arc in such a way it will touches the point number 1 and you will get a concentric arc like in this manner. So this is the final shape of the curve we used to get it. Okay. Okay, and the locus of center, that is very important. Here we need to mark it very clearly. The locus of center, see here, it is locating here, so it will be below the locus of 39 line. That's very important. So I will mark this locus of center with OC as radius. Just draw this arc. This is a very important one, locus of center. So we should not forget this thing. Okay, so you will get a locus of center like in this manner. Okay, and you can mark it also, nothing wrong with that. This is locus of center. Okay, now next step, what I am going to do is, I already divided the segments, right? We have drawn this particular arc at an angle of 72 degree. Now I am going to divide into 12 segments. So 72 divided by 12, if I am going to put, the value will be 6 degree. Am I right? 72 divided by 12, it will be 6 degree. So just measure the points. Okay. So if I am going to measure the point, you may get it like in this manner: 1 dash, 2 dash, 3 dash, 4 dash, 5 dash and 6 dash. So these are all the points. Each of points, it has been marked at an angle of 6 degree. By using the protractor, you capture all these points. That's very important. And 7 dash is here, 8 dash, you may get it like in this manner, 10, 11 and 12. Okay, so 7 dash, 8 dash, 9 dash, 10 dash, 11 dash and this is 12 dash. Now what I'm going to do is extend these lines from this O point. Okay, for example, this first point, it's joined with here, second point, seventh point, 8th point, 9th point, 10th point, 11th point. Okay, so it's a minor works, we have to do it very carefully. Now similarly extend this line vertically upwards, or you guys can able to do one thing. you can place your scale vertically upwards and capture this point. For example, a C1 is coming here, the center point, we can able to capture it also. The main thing is we need to capture the C1, C2. So please ensure that once if you divide the divisions, make sure keep your scale properly at the particular angle. You mark the distance, the C1, C2 points at the locus of center only. You don't mark somewhere else. Okay. And C4, C3 you get it here, and C4, C5 and C6. Right. So you get it nicely. And this is C7, C8, C9, C10, C11 and last one is C12. So these are the points, it's very important in C12. Okay, and C6 definitely it will be at the middle, there is no doubt about that. Now next step, what I am going to do is place your compass at the point C1, take the radius of the rolling circle and cut an arc. Where we need to cut an arc, that's very important. See here the first line where it is, first arc, yeah, it's here at the top, right? It's entirely different. So cut an arc in such a manner, you may get it like in this manner. Okay, and similarly C2, you will get it like in this here. Place your compass at the point C2 and cut an arc. Okay, C3, okay, and C4, and you will get it C5, and C6 definitely you will get it here. Okay, and C7 you will get it somewhere here, C8, C9, C10, C11 and C12. So you will get a curve like in this shape, something like you will get it like in this manner. Just see it here. So from these points, anyhow I will do a little bit correction here and join all the points in such a manner, you may get it like C4. If you're going to place it, just join this curve. So the curve's joining area is very much important. You may get it like in this manner. So the arc joining points, it tends to have cutters here, the correct location, you will have it like in this manner. And these are the various points where we got it. And the last one, it has to be joined with the first point, right? That's very important. So join with the first point, okay, or the 12th point. The 12th point is very important. So the arc cutting, it will be like in this manner. Okay, so I have plotted it here. So these are the points. Okay, 1, 2, 3, 4, 5, and the 6th point it will be here. 7th point arc cutting, 8, 9, 10, 11, 12. So once if you join all these arcs, you will get a wonderful smooth hypocycloidal curve. Just like this shape, you will get it like in this manner, and you will get it very perfectly. Okay, so do in a perfect measurement, you will get it exactly the hypocycloid curve very well. Okay, next thing is draw a tangent and normal at any point, right? The same concept I am going to apply it also here also. Choose any point on the curve. For example, let me choose this point. This point I am giving the name as M. Okay, now next step what I am going to do is join this M. Okay, after this, after capturing this point M, take the radius of the rolling circle, okay, and cut an arc at the locus of center. For example, I am cutting here. Place your compass at the point M and cut an arc at the locus of center with the radius 20 mm. Once if you cut the arc, right, join this point, you capture this point, right, join this point towards this O point. Join this point towards this O point. For example, let me give this point name as, let it be N, capital N. Okay, so join this N towards this P. Okay, so that is the next step we used to do. Okay, now here the main thing is, for example, instead of N I will make you some other name for our understanding purpose. You may have the, let it be the X, this point name is X. From the X we are joining to the 1. But the main concept what I told you is, here the base circle. Where the base circle here? Whenever you are capturing the normal line, where it touches the base circle. Yeah, this base circle is at the top in case of hypocycloidal curve. But right now, I have joined this point towards here. Similarly, you keep your scale backwards, extend the scale upwards in such a manner, it will touches this base circle. Extend this line upwards. Okay, it will till it touches the base circle. You capture this point. Yeah, this point only I'm going to give it as the name as N. Okay, you got it. What I've done? Place your compass at the point M. Take the radius of rolling circle. Cut an arc. Once if you cut the arc, join this point X towards this point O. Then similarly extend this line backwards till it touches the base circle. Because normal point always we will take from the base circle only. In previous epicycloid also we have seen. So capture this point, join NM. Join NM. This NM is, or you can extend this line also. Join NM, little bit extend it and give the name as N dash. This NN dash is called as a normal line. For this normal line, just draw a tangential line. Just draw a tangential line in such a manner it should be perpendicular to this. So for this normal line, just draw a tangential line till it touches the circumference of this hypocycloid curve. So this point is known as T dash, let it be T. This TT dash is called as a tangential line and NN dash is the normal line for this hypocycloid curve. So finally make a note of it. The TT dash is a tangent and NN dash is a normal. And similarly mark the dimensions. That's very important. So marking the dimension is very important. Just see it here. So the circular dimensions, it's very important. Extend the lines. And give the values. It's dia 40, right? Dia 40. And similarly base circle dimension. Yes. What is the base circle? It's from here to here, PQ, right? So the topmost. From here to here. Just extend this line and close it. And mark this value. Let it be, this value is how much? It is equal to R100. It's a radius, right? So I am marking the dimension as R100. Okay. So R100 is the radius of the base circle. So these are the two dimensions is important. Under that, at the right top corner, just write down a name. All dimensions are in a mm. So just write down that particular line. That's very important. So we are always giving the dimensions in terms of only. Okay. So this is the end of this hyperbola curve. Okay. And also we have drawn a tangent and normal at any point on the curve. Okay. Thank you viewers for watching.